Hi everyone, welcome back to Statistics and Data Analysis. Today we will start our introduction about descriptive statistics, and in particular today we will focus on how to use graphs to do visualization of your data. Okay, so let's start. Basically, in today and the next lectures, we will talk about some common ways to summarize a set of data. When you are given a set of data, typically you want to do at least two things to summarize or to visualize your set of data. One is to use graphs to give people a visualization of it, or you may want to use some numbers, or we say some statistics, to summarize the set of data. That is typically very important when you want to do a data analysis project. Okay, in this semester you are going to learn some specific techniques that may be helpful when you want to analyze your data. Okay, you may probably do some statistical methods on it or do some data mining works on it. But the important thing is that you need to first know or understand your data. Only if you do that, only if you understand your data, then you can choose the appropriate method to apply. Okay? Otherwise, you may just use a wrong method for a set of data, and the result, of course, can be useless. So the first step to do is always to describe, to visualize, or to summarize your data so that we can get some intuitions that may guide our directions of research. So today we will focus on using graphs to do visualization, and in the next lecture we will talk about to use statistics to summarize our data. Okay, so in today's lecture we will divide the lectures into four videos. In this one, we will talk about frequency distributions. Okay, basically it's about when you are given a set of data, how would you categorize it or how would you classify it into a few classes. And then the frequencies in each class will help you understand the distribution of the numbers. Okay, let's try it. So let's use the example of our bike rental data set to help you understand the ideas in this lecture. So remember that you can find the data set on SEBA. Okay, and let's think about the final outcome column CNT in the datasheet day. We know that those numbers there represent the numbers of daily rentals in each day. If you take a look on it, it will be some numbers like 985, 801, 1349, blah 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 blah. There will be 731 numbers, and when you look at it, they just look like random numbers. You have no ideas about what do they relate to each other and what do they mean. So to really get more ideas about the data set, what we want to do is descriptive statistics. Sometimes this set of methods are called exploratory data analysis. Okay, basically is to explore the set of data, to describe the set of data in a way that we may get some intuitions about it. For example, when you see a set of data like this, probably we want to know are these numbers in an increasing trend, or are most of the data most of the numbers close to the center or not, something like that. We want to first get some basic ideas about this set of data. Then we do descriptive statistics. One of the most important things that you may want to do is to build a frequency distribution for a set of ungrouped data. Okay? In that particular column, those original 731 numbers, they form a typical set of ungrouped data. That means those numbers are ungrouped. Okay, each of them, you won't say that they belong to this group or that group. No, each number is just one number, and you have a collection of 731 numbers. Okay, when numbers are ungrouped, visualizing them can be very hard, because if you plot 731 numbers on a plot, well, it typically does not tell you anything. So an easier thing for people to process, for people to understand your data graph, is to first group those numbers into a frequency distribution. We will group them so that we can use class intervals and the frequencies to summarize our set of data. So let's try to do one. Okay, what we want to do is to group the daily bike rental data set into a frequency distribution. So to make everything precise, let's label these numbers as x1, x2, and blah 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 up to x731. So for each number, there is a label. We use x1 to denote the first number, x2 to denote the second number, and so on. Then the first step is to find the range of this data set. The range is defined as the difference between the maximum and the minimum. Okay, in our example, the maximum number is 8,714. That's the daily rentals in the day that has the highest daily rental. And the minimum is just 22. There was a day that only 22 rentals happened in that day. So the maximum minus the minimum, we get the range. This single number is somehow something that tells us how this data set is dispersed. Okay, and once we get this number, well, we can try to decide how may we want to divide the range into classes. In total, we have this range, and we want to use a few classes to cover this range. Okay, these classes will be intervals with equal lengths, and a typical number of classes is between 5 and 15. So there is no standard way to decide how large a class should be, or how many numbers of classes you should have. Some numbers between 5 and 15 are typical, but no one tells you which number to use. So for example, let's simply choose 9. And once we have the range and have the class number, class width can be found very intuitively. We need to cover this length with 9 classes. So we need to make sure that our class width are long enough or large enough. With this single division, we can see that our class width must be at least 965 and something. So let's simply try 1000 as our class width. So we have decided that for each class, the width would be 1000, and we're going to use 9 classes to cover the whole range of our data set. Okay, so the resulting 9 classes that we design would be, the first one is from 0 to 1000, the second one is from 1000 to 2000, and so on, and the last one is from 8000 to 9000. One thing to keep in mind is when you describe your class intervals, you need to make sure that these class intervals are not overlapping with each other, and at the same time, they are continuous. Okay? If you combine all of them, they give you one single large interval with no hole inside it. So you need to make sure that here, when you describe your first interval with an open as an open set at the right hand side, then at the second interval it must include the left endpoint, which is 1000. Okay, so that means we are giving a very precise definition of our class intervals. You know when a number is 1000, which class goes to. Okay, when a number is 1000, it goes to the second class, not the first class. Okay, because we have this precise definition, then we know that. Some typical error. One of the typical error is here. You say the first class is 0 to 999, and the second class is from 1000 to 1099, and so on. If you are 100% sure that all the numbers would be integers, just like in this example, then it should be okay. This is okay for this particular set of data because every number is an integer. But if you have some numbers or some set of data where numbers may be fractional, then this can be very dangerous because you don't know how to categorize 999.7. Okay, so this is not a very good idea. This is not a very good way to describe your classes. You may also ask, well, may I include the right endpoint instead of including the left endpoint? No one says you cannot do that. Okay, so that means this is acceptable. But typically, when people do frequency distributions, people typically include the left endpoint. So it's just a typical convention. Okay. Once you have class intervals, then the next step is to simply count all the numbers one by one and put each number into one class. And eventually you will get the frequency distribution just like this. Okay? There are 18 numbers that belongs to the class from 0 to 1000. Okay? There are 18 numbers from 1000 to 2000 and so on and so on. Once we do that, then we have a set of grouped data. Okay, previously it's a set of ungrouped data with 731 numbers, but now it's a set of grouped data with 9 groups. So just to remind you, typically we have 5 to 15 classes. If the number of classes is too small, then well, it's just a too rough description. If there are too many classes, then people just cannot interpret it easily. Typically, we set all the classes to have the same width, so that these numbers can give you some better ideas when you compare different classes. Be aware of class endpoints, just as we mentioned to you. And one last thing is, if you have any outliers, they should be removed first. It's not just an issue about frequency distribution, it's about any data analysis job. So let's do some discussions about outliers. An outlier in the data set is a value that is, well, very weird. So it may be due to some very rare extreme cases that in typical cases we don't see it, or it may simply be due to a typo. In some cases, it's simply some unreasonably large number or unreasonably small numbers. If you can identify them, you may want to ask whether they are simply a result of typo. If that's the case, of course, you want to correct it. Or is it come from any very rare situation? If that's the case, you may also want to exclude it. For example, suppose on December 31, 2012, suppose on that date there was actually a promotion and all the rentals on that day was free. Suppose that's the case, and suppose the number of daily rentals was this number, okay, such a very very large number instead of 2,290. Suppose that's the case, and also suppose when when the officer were typing this data set, or suppose it was typed instead of collected automatically by a system, then suppose there was a mistake to make that 654 into 6544. Suppose that's the case, then our grouped frequency distribution would become this. Okay? Then you see that a frequency distribution would be very helpful if you want to somehow make a check about outliers. One situation that you will see is that, okay, we will get a very weird number here. Almost all the numbers are here, but there is a very large, a class that is very far from other classes. Okay, then it's quite likely that this is an outlier. And then you identify it, and then you ask why is that, and then you decide whether you want to remove it or not. This is easy, but some situations are not. For example, here, 654 becomes 6544. Okay, this is a very huge mistake, but you won't see a very obvious difference in your frequency distributions. Okay, so that means you cannot just rely on your frequency distribution to hope that all the outliers will be identified. Okay, in that case, you may need to read your data set more carefully. For example, if you really read each numbers one by one, then you will see that this number is unreasonably large because almost all other numbers on that particular month are quite small, but this number is so large. Okay, but anyway, you need to decide whether there is any outliers in your data set. You need to try to identify all of them before you do your job. Okay, that's the typical case. Okay, lastly, once we have a frequency distribution, we may want to add some more information into that table. Sometimes they are helpful. One thing we may want to add is class midpoints. Okay, here, for each class, you write down the midpoints of it and include it as one column. Or you may want to add relative frequencies, like here. Each number here means what's the relative frequency of that particular class, or what's the proportion of this class within the whole distribution, okay, the whole data set. Finally, you may want to add cumulative frequencies. That's the running total from the first class to the last class. In the first class, the number is 18, so the cumulative frequency is also 18. And then the second cumulative frequency would be 18 plus 80. So that's why this number is 89. And then in the next one, we add 74 to 89, and it becomes 172, and so on and so on. So that would be a column for cumulative frequency. And obviously, at the end, you will get 731. Okay? You may want to ask, is it reasonable or is it possible to add a cumulative frequency, relative frequency columns? Well, it can be done. Some people do it. And if you think that's helpful for your project, you can also do it. Okay, that's the end about frequency distributions. In later videos, we will use it again. Thank you.